Hello, everybody. Welcome back. Welcome back. How's the weekend? I I had a weekend. No, okay. It was half and half. Saturday was good. Saturday was really good. Lot of good family time. We went out to see my grandma. She lives an hour and a half away. So we went to go see her. Spent some time there. Had a Thanksgiving meal of sorts there. We came back, and that was the last day that my brother was in town. And so we watched we played some Fortnite. I think some of us played Fortnite, some others played a game, and then more people started playing Fortnite, and eventually we watched the Benedict Cumberbatch Grinch movie, which was a good time. But then Sunday was very hard. Yesterday, very hard. Won't get into details, but it was very, very hard. And then today, well, it's a bit of a hard season right now. In general, last week was a great week. Getting to spend all that time with family and stuff like that. But in general, behind the scenes, tough season of life. But we are getting into a new thing today. We are out of, I don't know what you want to, the XML stuff, the exercises. We're going to get into Python objects today. This might be a short stream. I'll be honest with you. It might be a short stream. If this is a short one, that will probably be what we do, because I want to get a little editing done, and there's just some other things I want to do tonight. I know it's late. I'm a night owl. It's just I love the nighttime hours. But anyway, without further ado, here we go.
Hello and welcome to Python Objects. I'm Charles Severance, and we're well on our way to getting through all this material in the Python.
Okay, warning. This lecture is very much about definitions and mechanics for objects. This lecture is a lot more about how it works and less about how you use it. You won't get the entire picture until this is all looked at in the context of a real problem. So please suspend disbelief and learn technique for the next 50 or so slides.
So this lecture is in a weird place. I even debated where to put it in the book. I don't really want to teach you how to write a lot of object-oriented programming, but we're going to start using objects, and I want to be able to use the terminology. And so as much as anything, this lecture is about terminology and understanding the words, things like methods and method signatures and variables and inheritance. And so think of this as a terminology lecture rather than a learn how to program or learn how to use this. It's not something you're going to figure out right away. And there'll come a time when you as a programmer really want to start using object-oriented programming. It's really a powerful and wonderful technique, but I think it's too early as a beginning programmer to really say, oh, let's write a bunch of objects. So just relax and enjoy and learn this material and think of it as sort of a theoretical thing rather than, a how to program thing.
Okay. I was too hot about pausing. Oh my. Data structures. This chapter. Do we really? This chapter describes some things you've already learned about already in more detail, and adds some new things as well. More on lists. The list data type has some more methods. Here are all of the methods of list objects. List.append. List.extend, insert, remove, pop. What is pop? Let's read pop. Remove the item at the given position in the list and return it if no index is specified. A dot pop removes and returns the last item in the list. Excuse me. Square brackets around the I in the method. Oh my word. I didn't even see that, this part. In the method signature, denote that the parameter is optional, not that you should type square brackets at that position. You'll see this notation frequently in the Python library reference.
And so part of this is we're going to start reading data structures, and I mean data on how to use all these libraries, etc. And we're going to see the word objects, right? And then we're going to start hearing them. And I want you to be able to read the Python documentation so that you understand what's going on. And so, you know, the word object should make sense to you, even though you're not going to write a lot of object-oriented programming. And so page upon
a C library. To use the module, you must first create a connection object that represents the database. Here, the data will be stored in the example.db file. Import SQLite3 con equals SQLite3 dot connect example.db. You can also supply the special name memory to create a database in RAM. Once you have a connection, you can create a cursor object and call its execute method to perform SQL commands. Connection cursor, execute, create table stocks. Okay.
On page upon page, database stuff, which we're going to talk about soon, is uses objects all over the place. And the beautiful soup uses objects. We've kind of been using them, and I've been waving my hands, and I use the word method without defining it. But now it's really time to define it and go to it. So I want to review from the very beginning what we think of as a program.
Okay.
So the classic program, my favorite little minimum program, is our little elevator floor converter, which converts from European elevator floors to United States elevator floors. And the key to this is that it's input, processing, and output. And this is a good way to model any program. And in that process, we've got variables, and we've got logic, we've got algorithms, we've got loops that we write, we've got all kinds of things. And we construct a series of steps to achieve some goal.
Object-oriented. A program is made up of many cooperating objects. Instead of being the whole program, each object is a little island within the program, and cooperatively... What? Each object is a little island within the program and cooperatively working with other objects. The program is made up of one or more objects working together. Objects make use of each other's capabilities.
In object-oriented, and frankly, you've been using object-oriented all along, the program has lots of objects, and we're sort of putting stuff into these objects, taking stuff out of one object and putting it into another object. And you've actually been doing this all along. As soon as you're looking at dictionaries and lists, you're doing objects. And so an object is quite a little thing. It's sort of its own little space inside of a program that contains code and data. And so we're working together. All these objects are now working together. It's a bit of...
Object. An object is a bit of self-contained code and data. A key aspect of the object approach is to break the problem into smaller, understandable parts. Divide and conquer. Objects have boundaries that allow us to ignore unneeded detail. We've been using objects all along: string objects, integer objects, dictionary objects, list objects.
Of self-contained code and data, and it is one way to take a very complex problem and make it easier by breaking it into separate things that can be engineered and developed separately. So you've been using string objects, or maybe you'd use Beautiful Soup or something. These are powerful capabilities, and if you had to look at all of them, it's just, hey, here's a thing, use this object, it'll do these things for you, and there's lots of details inside of it. Just don't look at it, don't worry about it. And so there's boundaries, that things that you can use, things that you can look at, and things that really you don't bother looking at. You go read the documentation and use it, and away it goes. But then someone had to write that, and so they built an object. So what we're going to do is look a little bit under the covers of what it takes to build some of these objects. And so if we think of this program that originally just sort of did processing, we can think of it as having some kind of an input, right, coming into our program. And we have a string object, a dictionary object, maybe eventually some objects like a database object or an object that we eventually define. And you can think of as we're receiving data, it comes in an object, which is a string object, where we start putting the strings in dictionaries and do whatever. We pull out a list of them. And so you can think of data as moving between these objects. And like I say, even strings in the first week, first lecture, first week, first everything, we were using objects, and we've been using them all along. And so you can think of every string and every dictionary as a little program all by itself that has a bit of code and a bit of data. And so a string has the data, which includes all the characters that make up the string, but then there is a method called upper that does uppercase, or rstrip that strips off the right white space from the right. Make up the string, but and so a string has the data, which includes all the characters that make up the string, but then there is a method called upper that does uppercase, or rstrip that strips off the right white space from the right. And so it's like they're almost little programs that have inputs and outputs themselves, and we can make lots of them. And there's lots of cooperating objects that make up an application.
Objects hide detail. They allow us to ignore the detail of the rest of the program. They allow us to ignore the detail of the rest of the program. I think I know what they mean. Like the rest of the program, as in what it takes inside the method and stuff itself.
And one of the nice things about the object-oriented pattern is that they form boundaries. And within the boundary, if you're inside the object, you can say, look, I'm going to build you a string object or a database object or a Beautiful Soup object. And I'm going to build this capability, and I'm going to give it to you in the form of an interface. And I'm not really going to care how you use it. And so we have this sort of visibility wall where I'm going to make an object and I'm going to let you use it. And the maker of the object doesn't necessarily have to know every single thing about the use of that object. But so just...
What?
Like where I'm going to make an object and I'm going to let you use it, and the maker of the object doesn't necessarily have to know every single thing about the use of that object.
I'm confused about how that works.
Visit object or a Beautiful Soup object, and I'm going to build this capability and I'm going to give it to you in the form of an interface, and I'm not really going to care how you use it. And so we have this sort of visibility wall where I'm going to make an object and I'm going to let you use it, and the maker of the object doesn't necessarily have to know every single thing about the use of that object. But so just like...
That's a little confusing. Objects hide detail. They allow the rest of the program to ignore the detail about us.
Like inside the object, they don't have to worry about what you're doing with the object outside of it. When you're outside the object, you don't have to worry about what's going on inside of it. We, as the user of the object, we talk to its interface and we get things from it and give things to it and use functionality within that object. But we don't have to look inside of this. We can just say, oh, it's a nice little magical thing. We read the documentation, we read a web page, and it told us to do this, this, and this, and away you go. And so it is sort of this isolation boundary that works both for the programmer who's writing the object and the programmer who's using the object. And
So it's basically like a trust system where it's like, this works. Trust me, you don't need to know how it works. And then like stuff is put in, the right stuff comes out, and it's like that, I think.
So it's a very nice pattern, and so you'll see how we're going to build code and we're going to group it together, and then we're going to be using it sort of as a big a blob of stuff.
Definitions. Class, a template. Dog. Method or message, a defined capability of a class. Bark. Okay, field or attribute, a bit of data in a class. Length. Object or distance, a particular instance of a class. Oh, like Lassie, so it's like a specific class. Okay.
So, some definitions in this space, words that I want you to understand. When we're going to create one of these things, one of these objects, instances, that has some data in it and some code in it, we have to be able to define the shape of this object. What code will each object have in it, and what data will each object have in it? And that's called a class. The key to a class, and this little picture that I've got up here in all these slides, is a key. The class is a template. It's not the thing itself. So it's a cookie cutter. It knows a lot about how cookies are made. And if you have cookie dough and you hit the thing, then you make as many cookies as you want. And so this nice little cookie picture is a great, mental model of how it works. The class is the template, and then the object are all of the cookies that are made from that template. But the template defines the shape and the nature of the class. So the code that we write is going of each are all of the cookies that are made from that template. But the template defines the shape and the nature of the class. So the code that we write is going of each of the objects. The code we write is the class code, and then later we say, oh, let's take that template and make ourselves an object or an instance. Now, as we're defining a class, made from that template. But the template defines the shape and the nature of the class. So the code that we write is going of each of the objects. The code we write is the class code, and then later we say, oh, let's take that template and make ourselves an object or an instance. Okay. Now, as we're defining a class, we have two basic things that we put in the class, and there's a couple of different terminologies for this. One is method, which is code. It's like a function that lives inside of a class. Not a function that lives inside your program, but one that lives inside of a class. And so this is a scoping thing. A method is really codes. Now, as we're defining a class, we have two basic things that we put in the class, and there's a couple of different terminologies for this. One is method, which is code. It's like a function that lives inside of a class. Not a function that lives the class template, but the class is the template, and then the object are all of the cookies that are made from that template. But the template defines the shape and the nature of the class. So the code that we write is going of each of the objects. The code we write is the class code, and then later we say, oh, let's take that template and make ourselves an object or an instance. Now, as we're defining a class, we have two basic things that we put in the class, and there's a couple of different terminologies for this. One is method, which is code. It's like a function that lives inside of a class. Not a function that lives inside your program, but one that lives inside of a class. And so this is a scoping thing. A method is really just a function, but it lives inside the class. And then fields or attributes are data items that are in the class. And so they're variables that are defined in the class. You can define variables outside the class that you use in your program, and you've been doing that all along. But if you're saying, I'm going to build this capability, and it's going to have data inside of it and code inside of it, the code is the method or message, and field or attribute. And they're just, inside of it, the code is the method or message, and field or attribute. And there are just two different sets of terminology. Method is what I'll probably use if you look in some object-oriented patterns like Smalltalk or Apple they often will call these messages. So you can either like access a method inside of a class or an object, or you can send a message to the object. The same is true for field and attribute. It's just a chunk of data that's in the object that you may or may not have the right to access.
Terminology. Class defines the abstract characteristics of a thing, object, including the thing's characteristics, its attributes, fields, or properties, and the thing's behaviors. The things it can do or methods, or the things it can do or methods, operations, or features. One might say that a class is a blueprint or factory that describes the nature of something. For example, the class dog would consist of traits shared by all dogs, such as breed and fur, color, characteristics, and the ability to bark and sit behaviors.
So, like I said, a class is a template. It defines the characteristics of the objects that we're going to use to make it. It is the cookie cutter.
Well, that was quick. Terminology, pattern, exemplar of a class. The class of dog defines all possible dogs by... What? A pattern, exemplar of a class. The class of dog defines all possible dogs by listing the characteristics and behaviors they can have. The object lassies one particular dog with particular versions of the characteristics. The dog has fur, lassie has brown and white fur.
So dog is sort of the exemplar. Lassie is a particular dog, and so dog has fur, and dog barks, and dogs do all these things, and so we know something about dogs, but it doesn't mean we have a dog, right? The class is a more abstract concept that when it's time to get a dog, we know certain things about dogs. Instances.
Terminology, instance. One can have an instance of a class or a particular object. The instance is the actual object created at runtime. In programmer jargon, the lassie object is an instance of the dog class. The set of values of the attributes of a particular object is called its state. Ooh, hold on a second. The set of values of the attributes of a particular object is called its state. The object consists of state and the behavior that's defined in the object's class. Object and instance are often used interchangeably. The object consists of state. The set of values of the attributes of a particular object is called its state. The set of values of the attributes of a particular object is called its state. The object consists of state. The set of values of the attributes of a particular object is called its state. The object consists of state and the behavior that's defined in the object's class. I think I get it. Okay.
Or objects. The class is a more abstract concept that when it's time to get a dog, we know certain things about dogs. Instances or objects are once we say, oh, time to make a cookie from the template, time to get a dog, we know something about dogs. That's the creation of an object, and that we call them instances, instance of a class. So the class is it doesn't exist, but we say, make me a new object using this class as its template. Oh, and now make me another one. And so we can have many, many objects from one class. So just like many cookies from one cookie cutter.
A lot of slides. Terminology, method. In objects, abilities. In language, methods are verbs. Lassie, being a dog, has the ability to bark. So bark is one of Lassie's methods. She may have other methods as well. For example, sit or eat or walk or save Timmy. Within the program, using a method usually affects only one particular object. Okay, all dogs can bark, but you need only one particular dog to do the barking? Oh, all dogs can bark, but you need only one particular dog to do the barking. That's confusing. Method and message are often used interchangeably. All dogs can bark, but you need only one particular dog. That's the confusing part. One particular dog. All dogs can bark, but you need only one particular dog to do the barking. Okay. So, like, you only need one to bark?
Method is a bit of code that lives inside of an object. It's like a function, but it's scoped to within the object or within the class. Okay, so that kind of gets us started on some of the terminology, and we'll come back and we'll take a look at how we write code that's object-oriented.
Woo! Alrighty. What is not, or which is not true about objects in Python? Objects are created and used, or excuse me, objects get created and used. Objects are bits of code and data. Objects hide detail. That is not true. Objects are one of the 5 standard data types. Because it's the class that hides the detail, not the objects. What? Well, it's that one, right? Wait. Oh, I'm dumb. They do hide. I'm stupid. They do hide detail. They do hide detail. I'm dumb. I was so confident, too. I'm like, they don't hide detail. They do hide detail. Because that's like the method thing. That's like, you know, blanket on a good one, but like just what we've been, like the capitalized one, right? Upper that hides detail. So they do hide detail. So what is it? One of the 5 standard data types? Yeah, that was it. Dang it. I didn't get that one right. All right. I mean, I got it right. I didn't get it right on the first time, I should say. Should clarify that. I obviously got it right on the second time. Anyway, that's the honesty. Yeah. Obviously got it right on the second time. Here we are. That is going to do it for today. Thank you guys so much for watching. If you enjoyed this video, please like and subscribe. Please post in the comments below if you have a prayer request. I would love to know how I could be praying for you guys. But that is going to do it for me for now. Love God, love people, and I will see you guys soon.